Hello everyone, I am Balaji Rao. Welcome to BR Maths class. This is ninth class in sequence and series chapter. We are doing this chapter in JE level. If you already learned sequence and series chapter from NCERT textbook, it is good. If you didn't learn this chapter earlier, it is you can understand this class. In last class, we learned what is geometric progression and we learned 6 important note points related to geometric progression. In this class, we will learn another few note points, around 4 5 another note points are there. We'll discuss those important note points related to geometric progression. If necessary, we'll do the problem also related to it. And especially what is increasing geometric progression, decreasing geometric progression, because in 2024, 2023 also they given questions if the terms are in increasing geometric progression, if the terms are in decreasing geometric progression, what is meant by increasing geometric progression, decreasing geometric progression, and sum of n terms of geometric progression, sum of infinite terms of geometric progression, all those things I'll try to cover in this video. First, let's see note number 7. Selection of terms in geometric progression. Sometimes what happens while solving the problems, they'll say that you choose 3 terms, they'll ask like this. Find 3 terms which are in geometric progression whose sum is so and so, whose product is so and so. They'll ask. We do one problem also. Let me finish this first. What is this actually? While solving the problems, they'll give like this. 5 terms or if 5 terms of a geometric progression whose sum is some 10 by 5, whose product is 20, then find those terms. Like that they'll ask. In that case, this is useful. See, this is the general pattern of geometric progression. AR square, AR power 3. This we learned in last class. This is the general pattern of geometric progression. With common ratio, if I write that terms preceding to it, how the term will be. Suppose what is the term preceding to A and whose it is in geometric progression such that the sequence is in geometric progression with common ratio R. Yes, its preceding term is A by R. You see, A divided by A by R is what? It is nothing but what is preceding to this term, that is A by R square. You can check here A by R divided by A by R square. This A will get cancelled. This R also will get cancelled one time. 1 divided by 1 by R is nothing but. You try to understand whatever terms I taken here. These forms a geometric progression with common ratio. While solving the problem, see, this is easy to memorize. This is why I written this here. This is easy to memorize. You already know general pattern of geometric progression. AR square, AR power 3 like that. And preceding terms also if you can remember. It is simple. A is there, na? A by R square, A divided by R cube, like this. In the question, if they given 3 terms are in geometric progression, whose sum is 20, whose product is 40, something like that they given, then we choose the terms like this. Look at this. A by R, AR. Why? Because when they give sum and product, especially product, when they give product of 3 terms of a geometric progression, you do the product of these 3 terms, what you will get? A by R into A into AR, R will get cancelled. Directly you will get A cube. Suppose the given product of terms is 8. Directly you will get A value is 2. See, in geometric progression, 3 terms are important. A, this is the first term. R is the common ratio. N, number of terms in the geometric progression. So, if they given 3 terms are in geometric progression whose sum is so and so, whose product is so and so, if they give like that, then we take those 3 terms as A by R, AR. Advantage of this is product of all these terms directly will gives you the value of A. If they given that 5 terms are in geometric progression whose sum is so and so, whose product is so and so. If in the question if they give like that, then we take those 5 terms like this. Look at this please. Look at this please. A by r square, a by r, ar square. See this one please. A by r square, a by r, ar square. If you know this full forms a geometric progression with common ratio r, choosing the terms because many students confuse to memorize these things. No need to memorize. Here one more thing is this odd number of terms, 3 terms, 5 terms like that. In case even number of terms are there, what you need to know here, in a geometric progression, if we choose the numbers in a regular interval, that also forms a geometric progression. For example, you take with this and leave one number. I am choosing these numbers at a regular interval. Please try to understand. Just leaving one number, I am choosing these intervals at a regular interval. These numbers also forms a geometric progression. How many terms are there here? These are 4 terms with common ratio r square. You can check this. A by r divided by a by r cube. This a will get cancelled. R square. 1 divided by 1 by r square is r square with common ratio r square. In the question, if they given 4 terms of a geometric progression whose sum is something, whose product is something they given, then we choose 4 terms like this. What is the benefit of choosing like this? When they give product of those 4 terms, you see here, when I multiply all these 4 terms, directly I'll get the value of a. I hope you understand this. We'll try to understand when we use this type of things with the help of an example. You see, this is question number 2 in geometric progressions. In arithmetic progression, we already done 40 questions. In that, many PYQs are there. You see here, find the 3 terms of a geometric progression. They are asking you to find 3 terms of a geometric progression whose sum is 21, whose product is 64. You find 3 terms of a geometric progression whose sum is 21 and whose product is 64. See, if you already done NCERT sequence and series, NCERT geometric progression, I request you to pause this video, try this your own. In case if you didn't get the answer, then check the solution. After reading the question, what I understand, they are saying that there are 3 terms or in geometric progression whose sum is given, product is given. So best method is, as they given product of 3 terms, I'll choose those 3 terms as a by r, ar. Their sum is given, that is a by r plus ar is 21, whose product is also given, product a by r into a into ar equal to 64. You can observe here this r will get cancelled. A into a is a cube. This 64 can be written as 4 cube. So directly I'll get the value of a. Now I got the value of a. See here, to find these 3 terms of geometric progression, we just need a value, r value. A value we already calculated. Now I need r value. What I'll do, I'll substitute this a value in this equation. You observe, I can take a common. Take a common. A is 4 into 1 by r plus 1 plus r equal to 21. So if I simplify this, what I'll get? 1 plus r square divided by r equal to 21. Further, if we simplify this, 4 plus 4r plus 4r square equal to 21r. You write it's as a quadratic in r, what you will get? 4r square minus 17r plus 4 equal to 0. You split the middle term. What you will get? 17r can be written as minus 16r minus r. Minus 17r can be written like this. Take 4r common. From this, you will get 2 r values. R equal to 1 by 4, r equal to 4. I got 2 r values here. That means I am going to get 2 set of numbers. I'll write here. In first case, I'll take a as 4 and r equal to 1 by 4. Substitute these values in this a by r, ar. A by R, that means 4 divided by 1 by 4, that is 16. A is 4. AR is 4 into 1 by 4, that is 1. You can observe here, they are in geometric progression. Check it. 4 divided by 16. Common ratio you need to check. 1 divided by 4. See, 4 divided by 16 is nothing but 1 by 4. They are in geometric progression. And in the question, they given that their sum is 21. You see, they are given that their sum is 21. The sum is 21? Yes. Their product is 64. This is one set of numbers satisfying both the conditions. You see the second case. In second case, I'll take A value 4 and R value is also 4. You see here, A value is 4, R value is 4. Substitute these numbers in this. A by R, that is 1, A, that is 4, AR is 16. You can check here, they are in geometric progression. 4 by 1, 16 by 4 equal to 4. Yes, common ratio is same. They are in geometric progression. You see their sum 21, their product 64. So in the question they are asking us to find three numbers of a geometric progression whose sum is 21, whose product is 64. So this will get two sets of answers for this question. I hope you understand this solution. Now few very important points are there. Once this theory is over, I do problems based on this note also. First observe this note. If A1, A2, A3 and so on An, like that, n terms are in geometric progression. They only given that these n terms are in geometric progression. Then whatever the reciprocals, if I choose the reciprocals of those terms, they also forms a geometric progression. They also forms a geometric progression. Very simple to check actually. You observe the common ratio. This term 1 by A2 divided by, I'll write here, 1 by A2 divided by 1 by A1 is what? It is nothing but A1 by A2. A1 by A2 is nothing but minus. You know that we already discussed in last class. AM divided by AN is what? Mth term, ratio of mth term divided by nth term is what? R power m minus n. So what I am trying to say, no need to discuss this point this long in JEE. If these n terms are in geometric progression, whatever the reciprocals you take, they also forms a geometric progression. Or else simple thing, you take three terms which are in geometric progression. Are they in geometric progression? Yes, they are in geometric progression. With common ratio is 2. Write their reciprocals 1 by 2, 1 by 4, 1 by 8. They also in geometric progression. What is the common ratio? Check it. 1 by 4 divided by 1 by 2, that is 1 by 2. So what I am trying to say, if n terms are in geometric progression, their reciprocals also in geometric progression. Keep this in your point. While solving the problems, I'll do problems related to this. Not only that, if A1, A2, A3 and so on, An are in geometric progression, if all these terms multiplied by with a non-zero constant, non-zero real number k, whatever you will get, that also forms a geometric progression. For example, 2, 4, 6, 2, 4, 8, 2, 4, 8, they are in geometric progression. All these you multiply with a constant. Suppose multiply with 3. Each term of this multiply with 3. 3 2s are 6, 3 4s are 12, 3 8s are 24. You check what is the common ratio. 12 divided by 6, that is 2. 24 divided by 12, that is 2. So if n terms are in geometric progression, if each term is multiplied by a non-zero constant, then whatever you will get, they also forms a geometric progression. This you can easily check with the help of an example. See here, multiplying is nothing but a type of a division only. See, A1, A2, A3 and so on, An are in geometric progression. If I multiply all these terms with 1 by 2, multiplying all the terms with 1 by 2 is nothing but dividing with 2 only. Here, these 2 points are almost same. So, if A1, A2, A3 and so on, An are in geometric progression, A1 divided by K, A2 divided by K, A3 divided by K, and so on, An divided by K are also in geometric progression for a non-zero K. See, after this note point, in arithmetic progression also we learn few things related to it. Quickly, I'll recall that also. In arithmetic progression, what points are there? Next, if A1, A2, A3 and so on, An are in arithmetic progression, if you raise the each term to power k, whatever you will get, they also 100% forms a geometric progression. See, all these things you can check by taking some examples. Suppose 2, 4, 8 only I taken. Raise each power to 2. Raise each power to 2, right? 2 square 4, 4 square 16, 8 square 64. Check these three terms are in geometric progression or not. 100%. 16 divided by 4, that is 4. 64 divided by 16, that is also 4. If A1, A2, A3 and so on An are in geometric progression, if each term of that geometric progression rise it to a power k, whatever you will get, they also forms a geometric progression. Not only that, as you are taking A1, A2, A3 and so on, An are in GP, if you take the orders in the reverse order, common ratio will vary, but whatever you will get, this An minus 1 and so on, A3, A2, 1, they are also in geometric progression. You can check these things with the help of examples. 2, 4, 8, are they in GP? Yes. 8, 4, 2 are in GP? Yes, they are also in GP. Check it. Common ratio 4 by 8, 1 by 2, 2 by 4, 1 by 2. So, if A1, A2, A3 and so on, An are in geometric progression, if you write them in reverse order, whatever you will get, that also forms a geometric progression. See, this is the point related to geometric progression and arithmetic progression. If they given n terms or in geometric progression, if we apply logarithm to each term, logarithm of a1, logarithm of a2, logarithm of a3 and so on, logarithm of an forms a arithmetic progression. These things you can easily understand. For example, three numbers a, b, c. If they given three numbers a, b, c are in GP, you know that when three numbers a, b, c are in GP, b square equal to ac. We learned this in last class. You apply logarithm to this on both sides. Apply what you will get, logarithm of b square equal to logarithm of ac into the base any number you take. Logarithm of b square is what? 2 log b equal to log ac is what? Log a plus log c. You please observe this. What this tells you? Suppose log a, log b, log c are in arithmetic progression, then what do you know? 2 times of log b equal to log a plus log c. You know this. Same thing we got. That means we got that if A, B, C are in GP, then what we got? We got logarithm of A, logarithm of B, logarithm of C are in arithmetic progression. And you observe this is if and only if condition. If A, B, C are in geometric progression, log A, log B, log C are in arithmetic progression. If they given log A, log B, log C are in arithmetic progression, if you remove this log of each term, whatever you will get, they will be in geometric progression. This is if and only if condition. The same, see, log A, log B, log C are in AP. They given like this. Then we will have this condition. From this, we can, by using properties of logarithms, you know, logarithm is not defined for all real numbers. It is defined for positive real numbers only. And you know the properties of logarithms. This can be written like this. From this, we will get this. From this, we will get this. This is if and only if condition. Suppose if I say 2, 4, 8 are in GP, log 2, log 4, log 8, they will be in which progression? They will be in arithmetic progression. I hope you understand this point. You see, they given two progressions A1, A2, A3 and so on AN, B1, B2, B3 and so on BN. They are in geometric progression. Two progressions are there which are in geometric progression. Then if we multiply the corresponding terms, whatever you will get, that is also in geometric progression. See here, A1 into B1, A2 into B2, A3 into B3 and so on, they forms a geometric progression. You can check these things with the help of example. You take two examples. For example, 2, 4, 8 is one geometric progression. 1, 5, 25. This is another geometric progression. Multiply both and you can check whatever you will get, that also forms a geometric progression. Not only that, you know that these are all the non-zero terms. What is a geometric progression? A progression, a set of non-zero terms are said to be in geometric progression if ratio of a term on its preceding term is always same. These are all non-zero terms. See here, a1 divided by b1, a2 divided by b2, a3 divided by b3. If you write like this, then whatever you will get, that also forms a geometric progression. These things you can check easily with the help of example. And one point is, if we add these things, or see a1 plus b1, a2 plus b2, a3 plus b3, they are not in GP. Not only that, a1 minus b1, a2 minus b2, a3 minus b3, they are not in GP. These things you can understand by taking few examples. Now we'll move to next point. See, as you learned just recently about this geometric progression related points, these points you learned, you just know what are the points we have in arithmetic progression. In arithmetic progression, these points are there. If these terms, n terms are in arithmetic progression, if each term added to constant k, whatever you will get, they'll form a geometric progression. If each term subtract with k, whatever you will get, that forms a arithmetic progression. This type of thing is not there in geometric progression. And you see, if each term is multiplied by k, you will get in arithmetic progression. This is there in geometric progression also. If a1, a2, a3 and so on, an are in geometric progression, if each term is multiplied by k, whatever you will get, that also forms a geometric progression. This is also there in geometric progression. If we take in regular interval, whatever you will get, that is in arithmetic progression. This works in geometric progression also. You see, A1, A2, A3 and so on are in geometric progression. The terms chosen in regular interval also forms a geometric progression. The terms chosen at a regular interval means here so many things will come. First, you take A3, A4, A5, A6 like that, 4 numbers only you choose. They are in a regular interval. This 100% forms a geometric progression because you know A4 divided by A3, A5 divided by A4, A6 divided by A5, because these are the terms from geometric progression. This forms a common ratio R. These are chosen in a regular interval. They forms a geometric progression. Not only that, here numbers are like this now: A1, A2, A3, A4, A5, A6, A7. Choose in a regular interval. First A1, next A3, next A5, next A7, like that. Choose it at a regular interval. That numbers also forms a geometric progression. These numbers also forms a geometric progression. You just check the common ratio. A3 divided by A1 is what? This is R square. You take any terms, A7 divided by A5. This is R square. We learned in last class how to calculate this A7 by A5. A9 divided by A7, that is also R square. These forms a geometric progression. These terms forms a geometric progression. Suppose terms are like this, they are in geometric progression. You choose in like this by leaving these two terms. Leave these numbers. So what you choose in like this: A1, A4, A7, A10. They also forms a geometric progression. How do you know that? Just check the common ratio. A4 divided by A1, A7 divided by A4, A10 divided by, that means 10th term divided by 7th term. All these things will gives you what? R power 3. Common ratio is same. You know how to calculate this, man. In last class we discussed AM. Mth in geometric progression, m ratio of mth term divided by nth term is R power m minus n. So what I am trying to say, if A1, A2, A3 and so on An are in geometric progression, then the terms chosen in regular interval also forms a geometric progression. You try to understand what is the meaning of this. This works in arithmetic progression also, you can check. Note 10. Increasing and decreasing geometric progression. See, in 2024, they asked a question based on this increasing geometric progression. In 2023, they asked a question on increasing geometric progression. So, many students knows what is geometric progression. What is increasing geometric progression? What is decreasing geometric progression? Suppose there are n terms are there or infinite terms are there which are in geometric progression. You know, this is the general pattern of geometric progression. AR square, AR power 3. They are in geometric progression. What is meant by increasing geometric progression, decreasing geometric progression? In this total 4 cases are there. You need to memorize these things, 4 cases. See, A is greater than 0 and R is greater than 1. You know, this is this geometric progression formed with two terms, na? AR, two numbers, AR. A is greater than 0, R is greater than 1, then it is a geometric progression. Why, sir? Why it is a geometric progression? We take one example and we will check. A is greater than 0, na? I'll take A equal to 2. R is greater than 1, na? I'll take R equal to 2. Easy numbers only we'll take. This is just an example. Na? You substitute this A value, R value in this. A is 2. AR is 4. AR square, that is 2 into 4. 8. AR cube, 2 into 8. 16. You can observe, are they in geometric progression? Obviously, as we substituted in this, they will be in geometric progression. Why it is called increasing geometric progression? You observe the numbers are increasing. 2, 4, 8, 16. Not necessary every time numbers must increase. We will learn that in decreasing GP. So, if A is greater than 0, R is greater than 1, common ratio is greater than 1, it is 100% increasing geometric progression. If A is less than 0, R is greater than 1, then it forms a decreasing geometric progression. That we will learn now. See, A is less than 0, R is greater than 1, then it forms a decreasing geometric progression. You need to know that in the question, if they given it is a decreasing geometric progression, possible cases A is less than 0, R is greater than 1. We'll try to understand this with an example. I'll choose A is minus 5. I'll choose R is 2. Substitute these values in general pattern of geometric progression. A, that is minus 5. AR, that is minus 5 into 2, that is minus 10. AR square, minus 5 into 4, minus 20. AR cube, that is minus 5 into R cube is 8, that is minus 40. You observe these numbers. These numbers are decreasing. Minus 5, minus 10, minus 20, they are decreasing. That's why this is called decreasing geometric progression. I hope you are understanding. If A is greater than 0 and R value lies in between 0 and 1, then it forms a decreasing geometric progression. We'll take one example. You take A is 3, R is 1 by 3. Substitute these values in general pattern of geometric progression. Substitute 3. AR, multiply these to AR, you will get 1. AR square, 3 into 1 by 3 square, that is 1 by 3. AR cube, 3 into 1 by 3 power 3, that is 1 by 3 square. If you observe these numbers, are they increasing or decreasing? 3. Next 1, decreasing. 1 to 1 by 3, decreasing. 1 by 3 to 1 by 9, decreasing. These are decreasing numbers. So, it forms a decreasing geometric progression. Similarly, you come to this, A is less than 0 and R value lies in between 0 and 1, then it forms a increasing geometric progression. Take one example. See, A is minus 2, R is 1 by 2. A is less than 0, no? That's why I taken minus 2. R is lies in between 0 and 1, no? That's why I taken R is 1 by 2. Substitute in general pattern. You observe these numbers as per number line order, minus 2, minus 1, minus 1 by 2, minus 1 by 4. They are increasing. So, if A is less than 0 and R value lies in between 0 and 1, then it forms a increasing geometric progression. So, we'll conclude. A is greater than 0 r is greater than 1, then what it forms? Increasing geometric progression or decreasing geometric progression? It forms a increasing geometric progression. Suppose a is less than 0, r is greater than 1, then it forms a decreasing geometric progression. Third one, a is greater than 0, r value lies in between 0 and 1. It forms a decreasing geometric progression. Fourth one, a is less than 0, r value lies in between 0 and 1. It forms a increasing geometric progression. With little bit of practice, you can easily remember this. I thought of completion of sum of n terms, sum of infinite terms in geometric progression in this video only. Because of the time factor, I am stopping this video here. In next class, we do that sum of n terms derivation in geometric progression, sum of infinite terms in geometric progression. I hope you understand this class. If you like this video, please drop a like for this video. Share this video to your friends groups. In case if you are not yet subscribed to this channel, subscribe now. Thanks for watching. Take care. Bye bye.